In section 10.3, we're going to solve quadratic equations by completing the square. And I'll show you what I mean by this. So, in the previous chapter, when we were factoring, we realized that we could, if we had a perfect square trinomial on one side, that we could actually solve by taking the square root of both sides. So here's an example of that. We have x squared minus 10x plus 25, which we realize is x minus 5 quantity squared. So we take the square root of each side and we get x minus 5 is equal to the positive or negative square root of 7. So that means that we have x minus 5 is equal to positive square root of 7, or x minus 5 is equal to the negative square root of 7. So we'll solve each of these equations and we'll get x is equal to 5 plus the square root of 7, and x is equal to 5 minus the square root of 7. And if we solve this on our calculator, we will get approximate answers, not exact answers. These are the exact answers, but when we plug it into the calculator, we'll get approximate answers. So let's see what we get. X is approximately equal to 7.6, or x is approximately equal to 2.4. So here's our solution set. Now remember, we could do this because the left side was a perfect square trinomial. But what if we don't have a perfect square trinomial? Well, we can make any trinomial a perfect square by using a procedure called completing the square. So let me show you what that means. You can make any quadratic expression a perfect square using a method called completing the square. So we're going to work in reverse here for just a second. Let's look at the method for squaring a binomial. And remember, when we do this, we square the first term, and we have 2 times the first term times the second term. So we have 2 times x times 6, or 2 times 6 times x. Any order is fine. Plus the square of the second term. So we have x squared plus 12x plus 36. And this is a perfect square trinomial. So let's see what we do to this middle term to find the value of the third term. Okay, if we took 1/2 of 12 and we squared it, that's 6 squared is equal to 36. And that's our third term. So we're basically working in reverse. First we multiplied 6 times 2, and now we're dividing it. Now we're taking half of the result. So we're dividing the result by 2. To use this method, we must have our quadratic expression in this form, x squared plus bx. So we need to move the c to the opposite side of the equation. Now right now we're dealing with an expression, not an equation. So I'll show you that next step in a few minutes. But right now, let's find the value of c that makes x squared plus 6x plus c a perfect square. Well, b is 6. So step 1 is to take 1/2 of b. 1/2 of 6 is equal to 3. Step 2 is to square that result. So 3 squared is 9. And step 3 is to add 9 to the expression. If this were an equation, we would have to add 9 to both sides. Right now we're dealing with an expression. So we're adding it to the original expression. So x squared plus 6x plus 9 can be factored into x plus 3 quantity squared. X plus 3 squared is equal to x squared plus 6x plus 9. Okay, in this example we were working with an expression, but let's see how we can solve an equation using completing the square. So here's our equation. A squared minus 14a plus 3 is equal to negative 10, and we're going to solve. The first thing we need to do is put this equation in the form x squared plus bx. So let's subtract 3 from both sides. Therefore, our left side will be in the form x squared plus bx. So if we subtract 3 from both sides, we have a squared minus 14a is equal to negative 13. Now, our b value is negative 14, so step 1 is to take 1/2 of b, which is negative 7. Step 2 is to square the result of that. Negative 7 squared is 49. And step 3 is to add it to the expression, but we're dealing with an equation, so we need to make sure we add it to both sides. We will rewrite our equation over here on the right and add 49 to both sides. On the left side, we have a squared minus 14a plus 49. And we can see that this is a perfect square trinomial. On the right side, we have 36. So let's rewrite this trinomial in its squared form. So we'll end up with a minus 7, oops, I wrote plus, fix that, minus 7 squared is equal to 36. Now we can use the method we learned in the last section to solve. We're going to take the square root of both sides. The square root of a minus 7 squared is equal to the square root of 36. Therefore, a minus 7 is equal to the plus or minus square root, the positive or negative square root of 36. So let's solve both situations. Let me get a little more room here. So a minus 7 is equal to, the square root of 36 is 6, so a minus 7 is equal to positive 6, or a minus 7 is equal to negative 6. So if we solve, we see that a is equal to 13, or a is equal to 1. And that's the solution, 1 and 13. And of course, remember from the graph that this means this is where the parabola will cross the x-axis, that is the zeros of the equation, where x is equal to 1 and where x is equal to 13. Now I'll rewrite the original equation so that we can check our solutions. Remember to always go back to the original equation. In case you made a mistake in solving the original, you will catch it if you go back to the original equation to do your check. So we'll plug in 1, and we get negative 10 is equal to negative 10, so 1 is correct. And we'll plug in 13 as well. And we will also get negative 10 is equal to negative 10. So our solutions are correct. Now in the examples we've done so far, the coefficient of the x squared term has been 1. What if the coefficient of x squared was not 1? Let's look at this example. Solving a quadratic equation in which a is not equal to 0. Okay, the path of debris from a firework display on a windy evening can be modeled by a quadratic function. A function for the path of the fireworks when the wind is about 15 miles per hour is h is equal to negative 0.04 x squared plus 2x plus 8, where h is the height and x is the horizontal distance in feet. How far away from the launch site will the debris land? So here's our equation, and we see that the coefficient of x squared is negative 0.04. So we want to, first of all, we want to find the solution when the debris hits land, which means that the height will be 0. So again, we're going to let h equal 0 in this equation. So let's set that up. Negative 0.04 x squared plus 2x plus 8 is equal to 0. And that's the equation we need to solve. So to eliminate the coefficient of the x squared term, we're going to divide. Okay, I drew a little picture here of what the fireworks will look like. They go up and they blow up, and then the wind blows them a little ways away, and we can see that y is going to be 0 at that point. So let's divide both sides of the equation by negative 0.04. And of course, on the right side of the equation, anything divided by a number is still 0. And on the left side, we need to divide each term by that value. So we'll end up with x squared minus 50x minus 200 is equal to 0. So to put it in the right format, to use completing the square, we need to add 200 to both sides. X squared minus 50x is equal to 200. So we need to look at our b term. b is equal to negative 50. So step 1 is divide negative 50 by 2. That gives us negative 25. And negative 25 squared is positive 625. This is the value we need to add to both sides. So the result is x squared minus 50x plus 625 is equal to 825. So x minus 25 squared is equal to 825. Now we can take the square root of both sides. So x minus 25 is equal to the positive or negative square root of 825. So our two situations are x is equal to 25 plus the square root of 825, or x is equal to 25 minus the square root of 825. This gives us x is approximately equal to 53.7, and we have to ask ourselves 53.7 what? Well, it was distance, if you remember. It was how far away the debris would land. So it was 53.7 feet. And the other example was x is approximately equal to negative 3.7. Well, we know that that's not a reasonable solution since it cannot be a negative distance in this situation. So the only reasonable answer is that the debris will land approximately 53.7 feet from the launch site. So for homework, do pages 542 and 543 in your textbook, number 35 through 49 odd. Please check your answers in the back of the book and email me if you cannot find your mistakes. I'd much prefer that you try to understand it now than next week when we're going to be way behind.